All right, this is the linear relation section of our review for our grade 10 academic course this year. So hopefully you remember from last year, linear relations are any relationship that can be represented by a straight line. Line, linear, connections right there in the name, which is nice. We're going to primarily focus on two ways of representing a linear relation with a formula. The first is y is equal to mx plus b. This is often called the slope y-intercept form because it uses the slope and the y-intercept appropriately enough. We're also going to use the form ax plus by equals c, which is called the intercept form. And we'll see that in a little while when we get to it. And off to the side here, we just have a little reminder. If we have two lines that look like that, they go on and on forever and never touch. They're called parallel. They have the same slope. And if we have two lines that meet at a 90-degree angle, they're called perpendicular, and their slopes are reciprocals. And a reciprocal just means if the slope of one is a over b, then the slope of the other one would be, I think it's negative reciprocals, whoops, negative b over a. So slope, represented by the letter m, can be calculated using the formula m is equal to y2 minus y1 over x2 minus x1. Given the points x1, y1, and x2, y2, and that these points are on the line. So we take the y-coordinate of the second minus the y-coordinate of the first to calculate how much the line has gone up, and the x-coordinate of the second minus the x-coordinate of the first to calculate how far it's gone to the right. And then we have the y-intercept b. This is the point where the graph crosses the y-axis. So thinking about it, if the line is crossing the y-axis, that means it has an x value of 0. All right. So let's start with a table of values here. Let's finish this in by observing the pattern. So we have x going 0, 1, 2, 3, 4, 5. It's going up 1 every time. And our y value is 4, then 7. So it's going up by 3. So we'd have 10, 13, 16. And then there's a typo on your sheet where it says 25, I think. That should be changed to a 19. Okay. So what is the initial value? Well, to find the initial value, we're going to look at where x is equal to 0. So when x is equal to 0, y is equal to 4. Therefore, our y-intercept b is equal to 4. The slope, well, let's try our formula. M is equal to y2 minus y1 over x2 minus x1. And when we're doing this, we can make our life a lot easier or more difficult depending on what values we choose for our 2 points. I am going to take the first 2 points because they have the smallest numbers. So y2 would be the y of my second point, 7, minus y1, which is 4. And x2 has to be the one that's with y2, so that's 1 minus x1, which is 0, which gives us 7 minus 4 is 3 divided by 1. 3 divided by 1 is 3. And now we can write the equation. So y is equal to m, which is 3x, plus b, which is 4. We can also have it as a word problem. We'll look at word problems a little bit more later, but it's important to just get an idea here that for a linear relation in particular, we're looking at an initial value, basically what happens when the x value is 0, when nothing else is going on, just a base starting value. And then we're going to look at the rate of change, which will be represented by our slope. So in this case, the cost of renting the hall for the fundraiser is $200 plus an additional $3 for each person. So this for each person or per person is a rate, $3 per one person. So that kind of is our indicator that it's our rate of change. We can identify our variables and things if we want to. In this case, we're going to say let C be the cost, which is going to be our Y value basically, and let P be the number of people. So anytime we have a word problem where the variables are not told, we do have to declare what they are. So the initial value, the y-intercept, when there are no people coming, the cost is just the $200. So B is equal to $200. And the rate of change, or the slope, is every time we get another person, the cost goes up by 3. So our cost is going to be going up by 3 per person. The slope is going to be 3. So rate of change is another way to think about slope. So if you see a rate of change, that's the slope. And we'll leave C to you. We've got one there for you to do on your own. Graphing linear relations. So hopefully this is pretty familiar by now. So we're going to be looking at linear relations in the form of y equals mx plus b this time. So we got our little dark gray box. It tells us we're going to graph the y-intercept. We're going to use the slope to create a second point, and then we draw our line through the points. So let's do A. For A, our y-intercept is 2. So when x is equal to 0, y is equal to negative 2. So when x is equal to 0, which is on this line, y is equal to negative 2. There's our first point. And then we have a slope of 3. So we're going to go up 3 for every 1 we go over. Rise over run. Rise over run. Because remember, anytime we have a number like 3, that's the same as 3 over 1. And then the rise over the run. So from our y-intercept, we're going to go up 1, 2, 3, and over 1. That gives us our second point. And if you have 2 points, you can draw a line. I often like going 1 more. I'll go up 3 and over 1 more just to get an even better set. And then I don't see a straight line option here. Let's see. No. I'm not going to be able to draw a straight line on here very well. So you'll have to do that one yourself. But yeah, just a nice straight line through those 3 points. Let's do a second one. That's a nice color. Let's go orange. So let's do C. So this time we have a slope of negative 1/2 and a y-intercept of 1. So y-intercept of 1 is where we're going to start. Y-intercept means we're right on the y-axis. And there's a value of 1. So that's our y-intercept. And then our slope is negative 1/2. So the rise, we tend to keep the negative with the rise, just to keep it simple. So the rise is -1. We're going to be going down 1. So we're going to be going down 1. And the run is 2. For every 2 we go to the right. So it's going to be down 1 over 2. Down 1 over 2. And then you can just draw your line right through there. A lot better than I am able to because you can use a ruler. So the other ones are for you to practice. Intercept form is the other way of basically presenting a linear relation. So in this case, we have the option. You could rearrange this as y equals, but sometimes the numbers can be really yucky. But what we can do is, if we set x equal to 0, then this whole term goes away. And the y-intercept will just be, we divide both sides by b, and we'll have y is equal to c over b for the y-intercept. Similarly, make that go away. If we want to find the x-intercept, we'll let y go to 0, and x will be equal to c over a, and that will give us our x-intercept, where it crosses the x-axis. Right. And then we graph those 2 points. Once we have 2 points, we can draw a line. So let's do a. So if 3x is equal to 0, we have -4y equals 12. So y is equal to -3. And if we let y equal 0, we have 3x is equal to 12. So x is equal to 4. So these are intercepts. So the points I have are 0, -3, and 4, 0. So 0, -3 is my y-intercept, and 4, 0 is my x-intercept. And then I can draw my line right through there. Perfect. Almost done. If you have a graph, we can get the equation of the line from it. You might have the instinct that the easiest one to pick might be the one where you get the x and the y-intercepts, but they don't necessarily line up with the axes quite nicely. And if we get a weird case like this, where we cross at the origin, we don't really know anything. So we're going to use our slope-intercept form whenever we're getting an equation from a graph. So the first thing we're going to do is find the y-intercept. Where does it cross the y-axis? So on this one, it crosses the y-axis right at the origin. So b is equal to 0. The y-intercept is 0. And then we need to find a second point that the line passes right through an intersection. So here is not a good point, here is not a good point, but that one looks like it goes right through the intersection there. So that would be the point 1, 3. So we have a point 1, 3. So now we have the point 1, 3 and the point 0, 0. So we can calculate the slope. Slope is equal to y2 minus y1 over x2 minus x1, which is 3. And if I did these points in the opposite order, it would work the exact same. I'd have -3 over -1, and my slope would still be 3, so it'd be fine. And then y is equal to m, which is 3x, plus b, which is 0. So you could write the plus 0 if you wanted to, but we usually don't. We would have y equals 3x. Last one for today. Sometimes we have a slope of a line, and we know a single point on the line, and we want to get the equation from that. There is a third equation for linear relations that can be used to solve this. It's not a skill that necessarily you're going to be able to translate into future learning. So I think learning this process is the better way. The formula is kind of nice and simple and you don't need to think, but that's exactly why we don't want to do it. We want to get used to the thinking along these ways. So we're going to be moving towards slope y-intercept form using the slope we've been given. Then we're going to substitute in the values for x and y from the point, because that point is on the line, which means it has to satisfy the equation. And then we will know everything but b, and we can use our algebra skills to solve for b. So in this case, y is equal to mx plus b, m is 2. So we have y is equal to 2x plus b. So we'll substitute in the points. So remember, that's my x, that's my y. So 5 is equal to 2 times 4 plus b. So 5 is equal to 8 plus b. I will subtract 8 from both sides to get b by itself. And I will have negative 3 is equal to b. And then I have my formula. Y is equal to 2x minus 3. We have another example for b. This time we have a slope of 3 over 5. So again, y is equal to 3 over 5 x plus b. We're going to take the x and y values from our point. So negative 1 is equal to 3 over 5 times 5 plus b. Here we have our fractional friend. We've got a divide by 5 and a times 5, so they cancel. So negative 1 is equal to 3 plus b. We'll subtract 3 from both sides to get negative 4 is equal to b. So y is equal to 3 over 5x minus 4. The rest is up for you to be able to practice with. Remember, at the start, we talked about what it means to be parallel. So parallel means it shares the same slope, and perpendicular means the slope will be the negative reciprocal. Or the negative flip the fraction upside down. That should be it. And we will see you back in class on Wednesday.